Microphone. Hey everyone. In theory, I'm live. I don't know. You're gonna have to tell me. I don't trust the internet. I don't trust anything. Welcome to Open Space for Monday, May 18th, 2020. You got that fun bonus episode yesterday. I hope you guys enjoyed that. My interview with Lord Martin Rees, the Royal Astronomer. Wow, was that amazing? Man, there's like some people that you never expect you're going to get a chance to talk to, and then you do, and they're super fun. We could have talked for hours. And I hope I get a chance to interview him again sometime in the future. What a legend. All right, so I hope as well people enjoyed last night's virtual star party. We had some great views of Saturn, probably the best pictures of Saturn we will see all season. I hope, I think Corey really nailed it. We're going to find out. We'll see the pictures in the next couple of days, and I'll post them as soon as we get them. But the great surprise was to be able to see, like in the springtime, it's galaxy season, and we got just these incredible views of all the different galaxies in the Virgo supercluster. And it blows your mind to think about this idea that we are in this city of galaxies, the Virgo cluster, supercluster, and you can see all the other members of this galaxy just by looking through a telescope. Like it's one thing to just kind of know they're there in a book, but it's another thing to just start pointing your telescope in different directions and just see them. So I think that was the picture. We took this shot of the Markarian's chain, where there's like, I don't know, a dozen plus galaxies all in this one image, and you just sort of gaze into the depths of the universe, and you're just sort of blown away. So anyway, it was a lot of fun. We got another virtual star party again on Sunday. Again, the process here is for us to just keep figuring this out, make them better, bring on more astronomers, different perspectives. I hope you really enjoy them, and we'll have lots more guests, different gear. So if you have any interest in astronomy, in becoming an amateur astronomer, if you want to learn more about how to use your gear, what objects to look at, definitely join us. All right, so let's get into this week's Open Space. Again, I have no plan, so this is all about you. Let me know your questions, and I will roll. All right. So Jim Smith asks, hey Fraser, here's the thing. If a singularity has infinite density, then why would it not have an infinite gravity in the universe? Black holes make no sense. Well, I think, definitely black holes make no sense. That you can just say with certainty. But the trick is with a singularity is we don't know what's going on inside the event horizon of a black hole. So all we know, the event horizon is that point at which the escape velocity from the black hole itself exceeds the speed of light. But actually what's going on within that region, once you get within the event horizon all the way down to whatever is in the middle, astronomers have no idea what that looks like. It could be a sphere that's just a little bit smaller than the event horizon, and that kind of makes sense, right? That doesn't mean infinite density. Or, as you say, it could be an infinitely small object. Even weirder, it could be collapsing nonstop, accelerating its collapse, getting smaller and smaller and smaller, and still compacting that same amount of matter into a smaller and smaller region and go, forever. We don't know. All we know is that there is something in there, and it has an amount of mass that has been compacted so tightly together that the escape velocity exceeds the speed of light. And all that astronomers can know is that they do have, that black holes, they can know that they have mass, and they can know what their spin is. But literally, that is all that astronomers can know about black holes. And maybe that's all astronomers will ever know. It's possible that you can probe features on the surface of the black hole, using things like super duper versions of the Event Horizon Telescope, or watching the final moments as black holes come together and merge into larger black holes. But still, there may be no way, and these parts of the universe are going to be beyond our understanding. So, yeah, it's kind of rough that there are parts of the universe that we don't know about and that we may never know. So, all right, let's see. So no, so Reverend RV, you're asking me if I've had any time to look into the advantages of being both in the liquid water habitable zone and the ultraviolet habitable zone, and the disadvantages of an exoplanet only residing in one zone. No, I have not. So, sorry. A.B. Scott and Flower. Conversely, if a person could be the size of a planet or a star, would their relative perception of time change due to their mass? Yeah. So one of Einstein talked about this idea that if you're going closer and closer to the speed of light, you experience a different amount of time dilation, right? But the other thing, because of his general relativity, is that in fact, as you are close to a larger mass, then you experience a different amount of time. And so if you were a black hole, if you were a planet, or a superplanet, or a very dense object like a neutron star, you would experience a different amount of time than the rest of the universe. The reality is you're doing it already. I mean, as you just exist and you contain mass, you experience different amounts of time than other people who contain less mass. So the fatter you get, the more time slows down for you, and then you get to live, from your perspective, a different amount of time than other people in the universe. I know it's kind of mind-bending, but that's just one of the implications of having mass. But of course, a planet isn't sentient unless it's, in the Marvel world. Keep in mind, though, I'm just a science journalist. I am not an astrophysicist. So if you're going to ask really detailed questions about astrophysics, we need to bring on a specialist. Horizon Brave, have you ever met or talked with string theorist Brian Greene? What are your own thoughts on string theory? Or is it just too theoretical for you? So just to follow on to that, no, I have not talked to Brian Greene. Maybe, Nancy, do you remember if we've ever interviewed Brian Greene? I'm sorry, they all blur together. I've read a bunch of his books. No, I'm pretty sure we haven't talked to him. I would love to. It would be fun. String theory has gotten a bad rap. I mean, the goal of string theory, right, is to unite the forces. And mathematically, from what I understand, it's a very fascinating way. Like the math just implies how gravity and the rest of the forces can come together and work in this sort of, in a way that explains all of the forces. The problem is that the kinds of experiments that would need to be run to be able to prove that this is the case are way beyond the capabilities of what we can do as in the modern day. So it may be that we may never be able to figure it out. But what's great is that even though, it might be making these predictions, it just can never be proven, the mathematics itself has had other benefits. So scientists have been able to use this mathematics to understand other extreme environments, and it has actually proven useful. And so I think that this is something, sometimes you never know what the result is going to be of your exploration. Sometimes you just start to explore, you tinker with ideas, and I can see why so much money has been invested. So many professors and so many scientists have done a lot of work, mathematicians, right? Because the math explains how gravity and the rest of the forces can all be one. That's incredible. That's the holy grail of physics. And so to not spend some time investigating that, it makes sense. And yet at the same time, you can see that people are investing, people are paying the salaries of these mathematicians, and they want results. So at a certain point, after these ideas have reached their dead ends, then mathematicians might move on. But from what I understand, there is still plenty of fertile ground for them to explore. So, Arjun, are you ever intimidated by the people you interview, or are you just normal with everyone now? How do you prepare? Um, yeah, I'm not intimidated really by anyone that I interview anymore. Definitely talking to Lord Martin Rees was sort of on the borderline for me, but he's just so easygoing and definitely made it easy to talk to. But no, I can't think of anyone now who I feel nervous. I mean, again, I've interviewed so many people, and I find that I'm able to lighten the mood and joke around with them I think the people who I would not get along with is the ones who aren't willing to, who feel insulted by my West Coast Canadian casual attitude. You know, we are, the rest of Canada thinks we on the West Coast are slackers and, are overly informal. And so I think that dealing with, someone who was expecting a certain amount of respect just purely through their title, I don't think we would get along very well. But if person's curious, they got great ideas, they want to talk about them, I want to talk about them, it's going to go great. So how do I prepare? Oh, I don't. I prepare by doing 20 years of work in becoming a science journalist. That's the main preparation that I did, was to understand this information. And even things like this, as I'm doing this live stream right now, it is just training for my brain to make me learn to be able to answer questions on the fly, to be able to see every flavor of every question and be able to think about them. And I'm able to put together all of these separate ideas and compact them into questions for the people that I'm talking to. But I definitely, I love if I can get my hands on their book, that's wonderful. So I can read and learn some of the things that they're thinking about right now. But I think one of the nice things about being so specialized is, as long as the person is dealing with space sciences, I can pretty quickly figure out what they specialize in and have a conversation about what they do. And if I don't know, then I get to be curious, which is wonderful as well, which is that I just get to ask questions and just find out more and more and more until, we've run out of time for the interview. F0, do you think that intelligent design is an acceptable scientific theory? Sure. Intelligent design, the idea that there is some kind of underlying intelligence that is responsible for life on Earth, is a plausible scientific theory that you could analyze, and people have, and it hasn't stood up. So when you make a hypothesis, you say, hey, what if aliens have made all life on Earth? And then you say, what would it look like if aliens made all life on Earth? And it doesn't look like aliens made all life on Earth. So you throw out the theory and you move on, right? That's what science does. While on the other hand, the fact that all life on Earth is interrelated and evolved from common ancestors stretching back over hundreds of millions of years to some initial common ancestor, that's well supported by the evidence. And so you want to follow that direction because it's a lot more fruitful. And I think the problem, of course, with intelligent design and things like that is that people are coming at this with they're looking to validate a worldview that they already have. They have the conclusion. The conclusion is that a god or gods or aliens created life on Earth. And now they're looking for evidence that supports their belief. And that is a classic cognitive bias, right? You're coming with the conclusion, and now you're looking for evidence. You're cherry picking the evidence that supports this conclusion. And that's bad science. The best way to go is that you come up with a hypothesis, you test the hypothesis. If you're able to, if you're unable to not confirm, if you're unable to validate your theory, then, and it continues to survive, then, there's more and more likelihood that this theory is true. And as soon as you find any kind of evidence that disproves it, you have to throw it out. And that's the problem, is that, if you if the theory can't survive and you keep holding on to it, then you're not interested in science. You have a preconceived notion. You have a plan, and you are just looking to cherry pick evidence to confirm it. And so that's what I think. Let's see. So Sergusi asks, hey Fraser, why don't we see any practical applications based on either string or even quantum theories nowadays? Now, quantum theories, you totally do. Are you kidding? Like a modern computer is completely based on the theories of quantum mechanics. So much of our modern existence depends on the highly predicted and very accurate measurements made by quantum mechanics. There is another, and I apologize, I don't have this ready, and maybe somebody in the chat can mention this, but like I said, there's been a few fields of mathematics that have been helped out by string theory, and I forget exactly what it is. There's like I feel like it's in computers or it's in astrophysics, and so it's like the math that was used to develop string theory has found practical applications, but I don't remember exactly what it is offhand. But I will, I have found a gap in my knowledge, and I will fix it for next time. Man, Beth Johnson, who's your wish list to bring on the show? To be honest, I am literally out of wish list. We are so way beyond me having any sense of who I would and wouldn't like to bring on the show. I mean, I've had a chance on the various shows, right? I've had a chance to interview astronauts. I've interviewed people who've walked on the moon. I've interviewed various heads of NASA and various other space agencies. It's incredible, and I no longer, it's all a blur to me at this point. And what's wonderful is I ever even have a notion of somebody who I do want to interview. It's pretty easy for me to be able to interview them. And so the part that I really enjoy is not who I get to interview, it's who you make me interview. And of course, if you're a member of the weekly Space Hangout crew, and really just anything, right, is that people go, oh, it would be really cool if you talked with so-and-so. And I'm like, reach out to that person and invite them on one of the shows, and I will interview them. I'd be glad to do it. I'll do my part, which is to interview them, use my reputation and clout to be able to, get an interview. But that's far more satisfying to me, is that, you have people who you want interview, and I'm able to interview them for you. Therefore, yeah, people are proposing Elon Musk. Sure, that would be great if Elon Musk wants to talk to me. I don't know. I mean, I feel like, there is like this pyramid of people, and the people at the very top, everybody wants to interview them, and they're super busy, and you never get a chance to talk to them. But then as you sort of move down this pyramid, there's people who are doing really interesting work, and nobody wants to talk to them, and I want to talk to them. So I'm less interested in interviewing those celebrities that are at the sort of the tip of the iceberg. I would much rather interview the people who are doing a lot of really interesting day-to-day work, as opposed to necessarily going after celebrities, especially people who maybe are doing less of the work these days and more of the being a celebrity. So, Zach, do you think that there are alien bodies at Area 51? No, I don't. But who knows? But it would be pretty weird if there are alien bodies at Area 51. Let's see. There's a lot of great questions. Thanks for bringing them on. Man, I'm kind of overwhelmed now. Let's see. I apologize. William Beckham, any chance of getting Kip Thorne or Charles Misner on the show to talk about gravitation? I return the question to you, William. You should join the weekly Space Hangout crew. They will give you your executive producer privileges to invite people onto the show. You can reach out, say you're an executive producer of the weekly Space Hangout or of Fraser Cain, and you would like to schedule them for an interview on my show. And And then they have to decide if they want to insult me in this prestigious show, or they're willing to come and do an interview. Especially when they've got a book. When they've got a book recently published, they are generally in a mood to promote what they're working on, and they're very easy to book for guests. So again, I'm just one man. So join the Weekly Space Hangout crew, wshcrew.space, and they will put you to work, inviting your dream guests, and I will interview them for you. But I don't have the bandwidth to organize it. Paul Thacker, I hear if you fell into a supermassive black hole, you wouldn't notice passing the event horizon. What about when you're halfway through? Brain-heart signaling would break the laws of physics. Yeah, so the idea with these supermassive black holes is that their event horizons are so big, and the slope of the gravity well is so smooth that as you fall through the event horizon, and of course then you can never escape, because now you need to be going faster than the speed of light to escape, or the escape velocity, and that's impossible. Of course, even if you could go faster than the speed of light, you can't escape a black hole. But you are falling into the black hole, and you don't even feel it, because you're just not feeling those tidal forces. Now you're falling, and you can't stop this fall, and you're accelerating faster and faster as you're nearing the speed of light. And who knows what happens to your body and your brain, but eventually the tidal forces will tear you apart, and you will be gone. So yeah, but we don't know what happens inside. But it is kind of amazing to think that you could pass through the event horizon of a supermassive black hole and not even feel it, not even know, but you're doomed, which I think is great. Let's see. Neko Girl asks, do you think we'll get a grand unified theory within our average lifetime? So will we have a theory that has been experimentally proven, like the Higgs boson, that unifies gravity and the rest of the forces, right? Electromagnetism, the strong and weak electromagnetic forces. And will that happen within my lifetime, within your lifetime? I don't think so. I hope we do, but I don't think that we will. And if you asked me that question maybe 10 years ago, I would have said yes, because physicists were right on the edge of being able to detect the Higgs boson. They were pretty sure that it was there. And then the Large Hadron Collider would be used to probe this idea of supersymmetry and start to build a larger idea of how the universe works. But so far, the Large Hadron Collider has done a wonderful job of proving that the Higgs boson is there. It has done its one job perfectly, but then it has failed so far on all of its other jobs, which is to help give particle physicists just like some idea where to go next. Because right now, they have all of these various theories, and yet so far all that the Hadron Collider is doing is disproving various possibilities, but it's not providing any evidence in any one direction on where to go next. And so that means that all of the current ideas for how the universe works are kind of fundamentally missing a big piece about how the universe works. And so we're kind of back to square one. And then if you are back to square one, then it's going to take a while to get to square two. And so I don't know if it'll happen in my lifetime, but that's okay, right? Like, what's fun is the mysteries. And I mentioned this a bunch of times. Like, I know there's a lot of people that get really frustrated by this idea that we don't know, like, we don't know what dark matter is, or we don't know what dark energy is, or we don't know what, why there's more matter than antimatter in the universe. And that's fine, right? Like, who says that we get to have all of our questions answered? Maybe we have to live in mystery for a while. And yet, when you think about the ages gone by, people didn't know they didn't know how plate tectonics work. They didn't know how life changed. They didn't know how, how gravity worked. They didn't understand what light was. Like, there's all of these. They didn't know how the sun worked. And you can imagine people talking about nuclear fusion in the sun. I'm like, I don't like it. I don't understand it. The sun is, I've never seen a ball of thermonuclear explosion. I know coal, there's fire. I don't get it. I don't like it. There are mysteries, and the various ages of humanity have lived through these mysteries. And we stand on the shoulders of giants, and we get to know the answers to all of these questions. And yet there are questions that we don't know the answers to right now. And then there are questions that we don't even know that we'll want to ask. And that's for the future generations. And we all play our part in this sort of grand sort of pathway through science and knowledge. So, we're playing our part in the middle of this. And I think, I know I'm kind of ranting here, but I was going to keep going. The whole thing with the coronavirus, we feel like we have experienced, some of us, some of us who are older have experienced dramatic events that have happened, 9/11, the moon landings, Vietnam War, World War II, things that happened before that. And we are experiencing an event that is as big as some of these events in history. And it's like it's our turn to know what it feels like to be in a time that is dramatic and unprecedented, and we don't know what the outcome is, and it is anxiety inducing and frustrating and terrifying. And that is the human experience. The calm and peace and prosperity that we've had is rare, and we've become comfortable to it. And this is like just like a reminder that we are connected to those previous generations that came before us. Okay, so Jameson, 1776, thoughts on Blue Origin. Just kind of screwing around, or a giant about to wake with their secrecy and all? So I guess the question you're asking is Blue Origin for real? They have sort of walked step by step with SpaceX, and yet SpaceX is the one that has launched a ton of rockets. They land on their landing pad. They've launched the Falcon Heavy, which lands 3 engines at the same time. And how can Blue Origin compete with that, right? And so when you sort of look at all the different pieces, Blue Origin has tested a bunch of the individual parts. They've tested their rocket, the BE-3 rocket, which is a methane-powered rocket, similar to what the Raptor engine is. So in fact, they've sold licenses of this rocket to other rocket companies. So clearly this has been proven to the comfort level of people who are involved that this rocket is for real, that this engine is for real. Blue Origin has demonstrated with the launch and landing of its New Shepard rocket again and again and again that they have dialed in how to launch a rocket and then have it land on its landing pad again, quickly, with a very rapid return rate. So obviously the forces involved to go orbital are next level. The New Glenn is a jump ahead of pretty much all but the Falcon Heavy. So it's in its fully reusable mode. The New Glenn is the most powerful rocket that's going to be on the marketplace, except for the Space Launch System. But that's a whole other conversation. And so will they pull it off? I mean, we've seen videos of them building the fairing, the launch fairing, which is just enormous. And we should see this thing launch in the next couple of years. And I don't think we're going to see, the question is, does the secrecy and does the careful planning, was that the better path than SpaceX's just do this all in public, smash up rockets, try and try again until you get there? And my gut says no, that rapid iteration, rapid testing, learn from your mistakes, iterate is the way to go. But I have definitely seen a lot of progress, and a lot of people who I respect do respect what's happening. And also it comes without the drama. And so I think that we may find. I mean, they've grabbed a bunch of contracts, big contracts from NASA. There's a lot of really smart people working at Blue Origin. So, but again, kind of like, again, here we are at this moment here in 2020 where we don't know the result of this race. Talk to me again in a year. Talk to me again in 2 years, and we will know the outcome. And that's amazing. So, I can't wait to find out what happens. And then, of course, if Starship works, then all bets are off. And then Blue Origin's going to have to start again with something even more powerful. All right. Dr. Ed Elcott, cryptozoologist, did the U.S. build up by not building the Hadron Collider in Texas? Up until the discovery of the Higgs boson, I think people were it definitely felt like a mistake. So back in the 1980s, the US was going to be building this thing called the superconducting supercollider, which would be like a super duper version of the Large Hadron Collider with a lot more energy, a lot more power, the ability to probe more exotic particles. And then the project was canceled, and the Europeans took over and continued to fund and develop the experiment. And at the time, I think a lot of people thought, oh, that was a mistake. But I think it turned out that because the Large Hadron Collider sort of was able to detect the Higgs boson and no more, that maybe the superconducting supercollider would have reached the same problem. So I don't know. Now in retrospect, it might be. I mean, there's one group of people that wants to just build a more gigantic collider and then just start smashing things together at random to find out what happens. And there are other people who think that's a terrible mistake, that with that kind of expense, you want to carefully direct the money to come up with an outcome that you want to be more directed about it. You're looking for specific particles with a specific outcome, and that defines the kinds of experiments you do, the kinds of detectors that you build. So it feels like it's time to take a pause, continue improving the Large Hadron Collider, but let the theorists catch up with the experimenters and provide a whole bunch of, like the theorists provided the experimenters just a mountain of theories, and the experimenters disproved them all. And so now it's time for more ideas, more creative ideas. And so that might be that it's time to sit down and think about ideas, test the ones you can with the hardware that you have. And when the backlog of interesting ideas is overwhelming, then build the next big experiment. So, Reverend RV, you're talking about the ultraviolet habitable zone. Because I have no idea what you're talking about. Like, I understand it's probably, I'm sure I could do some research and maybe even do a video on it if it's really interesting. But I just recommend a guest. Find somebody who is doing a lot of work in this area, and then I'll interview them, and then we'll get to the bottom of this question for you. So I throw the ball back into your court. All right. Snappy Jams. You think Grimes will ever make any good music like she used to make ever again? Give her a break. Just had a baby. That's rough. Are you kidding? Man, your productivity is just torn up when you're a new parent. So, the only reason probably Elon Musk is because he's had more practice. But boy, man, having a kid, it's tough. Zach, do you think the time really moves backwards if you go faster than the speed of light? The math says yes. So the math says that if you can move a mass faster than the speed of light, then time will go backwards. But it's impossible to go faster than the speed of light. Therefore, it's impossible for time to go backwards. And you're saying, like, but what if we go faster than the speed of light? Well, what if you do the impossible? But according to the laws of physics as we understand them, it is impossible to move through space at faster than the speed of light. And I'm sorry. Like, I know that science fiction, Star Wars and Star Trek and Stargate showed you that it was possible, but it's just people using their imagination. Doesn't mean that this stuff is true. We may have to do things the hard way. Delicious plum. Is it my imagination, or did the Perseverance rover already land on Mars? No, it's not until July for Perseverance to go to Mars. The most recent thing that happened with Perseverance is they tucked the rover away into its heat shield. So you've probably seen some cool pictures of the rover inside the heat shield, and they attached the helicopter on the bottom of it, which is pretty cool. And no, so we're still looking for July. And then it's going to take probably about 9 months to cruise to Mars before it actually finally lands. We're going to go through that whole 7 minutes of terror, 9 minutes of terror, where the spacecraft makes its way through the atmosphere and land. So, David Reynolds, why did he go right by my question I paid $10 to ask? So just to be clear, for the people who are donating money, like, if you want to donate money, that's awesome. I am trying to sort of get through as many of the questions as I can. And, I try not to provide any emphasis specifically on people. So just be clear, about that my, my emphasis is to just, I'm not sort of, it's not like pay for access. So, if you want to donate because you enjoy the work that I do and you enjoy the videos that I make and the podcasts and the interviews and all that kind of stuff, that's wonderful and we appreciate it. But it is not necessary. It is, I'm able to do this work. We get advertising from Universe Today. We have our patrons. So thank you for your support. Your question, do you think it would be possible to jumpstart a rocky planet's core in order to get a magnetosphere that could protect astronauts and colonists as well as creating a stable atmosphere? And so the answer is probably, but the kind of damage that you would have to do to a planet to make that happen would be catastrophic and make the planet uninhabitable for millions of years. So it would be counterproductive, right? So if you hit, say, Mars with Ganymede, right? Then you would end up with a planet which is more massive than Mars. Maybe now it would have, I don't know what Mars is. Mars is like 10% the mass of the Earth, so maybe it would have like maybe 15% of the mass of the Earth, and it would now be liquid, right? Liquid molten metal. And then it would cool down. It would be as if it had formed at the beginning of the solar system, and it would have a magnetosphere in the beginning. It would have this crust in the beginning, and it would be, as it was cooling, then the metal inside of it would be rotating, and it would probably have but the magnetosphere might be terrible, right? Not very powerful, not as powerful as we would want with something like Earth. The key with the Earth is that it just has so much mass, like 5.6 septillion tons, right? Like, you just need a lot of stuff located in one location, and you need the right kind of internal elements for that to work. So the way and so you think about the forces and energy involved to be able to liquefy Mars. You've got to add enough energy to Ganymede. And maybe, probably Ganymede's not enough. You're going to need all of the Jovian planets. You're going to have to go out to Jupiter. You're going to have to move the moons away from Jupiter, crash them one by one into Mars, wait for Mars to cool. And then you've got for less radiation on the surface of Mars. Or you just dig underground. You just pile a little dirt on top of yourself, and you're protected from the radiation. So, I think that we don't know, right? We did an episode a couple of years ago about some ideas to generate a electromagnetic field on a more local level. So, could you surround yourself? Could we use like a super conducting magnet to generate an electric field that would be able to redistribute particles? And the answer just keeps coming. Like, again, NASA and other people have been searching for an answer to this for 50 years. Like, it occurred to them back then, and one after the other they've tried to come up with a way to do it, and it's always ended up being, it's more economical to just surround yourself with dirt, with metal, with water, than it is to try to generate some kind of artificial magnetosphere like what the Earth has. And, just tack on protection from radiation as the long line of things that that the Earth gives us. It lets us breathe. It protects us from radiation, gives us gravity to be able to stand. It's awesome. Aturuxo. I can't find the big red question mark. So, Fraser, how far do you think that we are from an honest to Clark, that's awesome, torch ship? Do we need to stop considering nuclear a dirty word when it comes to rockets? We did a video about a year ago about how NASA is sort of starting to consider nuclear rockets again, which is pretty great. And I think that you don't want to launch them from the Earth for various obvious practical reasons. But once you have taken your spacecraft up into orbit, then who cares, right? Fire the nuclear rocket. And nuclear rockets have a much higher escape velocity of the particles that are coming out of the propellant. So they make a ton of sense. And in fact, there have been several nuclear reactors that have been launched to space. So yeah, I think that we're going to see a fairly serious investment from NASA over the coming decades to try and make practical, nuclear fission rockets. We need a lot more fundamental understanding of fusion before we can get proper fusion rockets. But either case, a fission rocket, fusion rocket, they don't really give you what you need to be able to make interstellar travel, because both of them still will run out of fuel. You pretty much need a methodology for the only feasible idea right now that has been thought of to be able to send a spacecraft to another star system is to use something like lasers and solar sails, where you zap your solar sail with a laser, it accelerates it to 10% the speed of light, and then it somehow slows itself down when it reaches the destination. And so I think that that's probably the best solution, because even a fusion rocket is going to run out of fuel. A fission rocket is going to run out of fuel. You need something where fuel isn't a problem. Arjone, is the strength of the collider completely based on size and not on technology? Could they make a bigger collider that is not physically bigger? So the way the particle accelerators work really is that they are taking streams of protons and they are accelerating them in this big ring. And you need a ton of electricity, and essentially you are torquing these protons around and around in this ring, making them go faster and faster until they're really, really, really close to the speed of light. And what you get is the velocity of the protons is combined with the mass of the protons, so that when they collide, the combined energy of that freezes out into new particles. And so in order to be able to give your particles more energy, you need to run them at a faster velocity. And at a certain point, you can't generate the magnetic field that these particles are blasting through and going around and around, just can't be held in by the most powerful magnets that we're able to make. And so you make a bigger ring so that now you're not having to turn as tight a corner. And so you can get those particles up to faster and faster speeds. And so eventually the best possible thing would be some kind of particle accelerator that takes the particles all the way around the Earth, right? Around and around and around in a perfect circle. And that would use the smallest amount of magnets, or essentially you would be able to run this accelerator at the fastest possible speed and generate the most energy, so that when these particles collide, you are generating you are freezing out the most energy into brand new particles. Mike McHugh, what do you think about connecting yourself to AI via Neuralink in the future? It's interesting. I've said on several cases that I expect to have my robot body. So, and on the other hand, I'm completely squicked out, of course, by somebody operating on my brain. And so maybe as I get old and sick and death comes for me, I will be willing to take that risk of having Elon Musk and his friends drill into my brain and let me connect to my robot body. At some point, I'm going to have to, commit to the robot body thing. So, I'm squicked out by the idea of somebody drilling electrodes into my brain. And at the same time, I think that there's a lot of people who are deeply, have some serious issues like blindness or palsy or Alzheimer's. There's all kinds of really awful diseases that have affected people, which it sounds like this kind of technology would be incredible to help them out. And that's how we'll see it, right? Is we'll see it being used for therapeutic purposes for a decade. And this person was blind and now they can see, and it's all thanks to the Neuralink. And now this person couldn't walk and now they can, and it's thanks to the Neuralink. And then this person, has trouble remembering people's names, and now they can't, thanks to Neuralink. And this person used to be mediocre at chess, and now they're a world champion, thanks to Neuralink. That's how we all get turned into robots. So, it's just a matter of time at this point. Just sneaks up on us. All right, let me look for another question. Leonard Lindstrom. What will happen first? Humans return to the moon or the 30-meter telescope is completed? All right, so humans should be returning to the moon by 2024. The 30-meter telescope is 2025. So my guess is we get the 30-meter telescope before we get humans returning to the moon, because I'm guessing the return to the moon gets delayed by at least 2 years, probably 4. So my feeling is that we're going to see that the first moon landing in probably 2028, not 2024. But especially now with Corona, there's a real excuse, right? It's that people can't interact. Therefore, they aren't able to work on the engineering involved. But there's just so many things that all have to come together perfectly in time. Like, think about where we are, right? We're in 2020, so we're 4 years away from the moon landing. We need a rocket system. We need a lander. Right? We need a way to get, we need some kind of, if we're going to use the deep space gateway, we need a deep space gateway. So all of those are required. Beth Johnson, have you watched the show Upload yet? Yes, I loved it. Mostly just because it's a great show. It tackled a lot of the issues of what it would be like living in a virtual world quite well. I'm really looking forward to Space Force, of course, and it's by the same people. So I can't wait. FEP PTCP on the exploration of the subsurface ocean of Europa. Why doesn't humanity explore the deepest points of Earth's ocean first? Are those places already properly studied? What is more difficult? Studying the bottom of the ocean is probably more difficult than studying the surface of other worlds. To a deep extent. When you think about how, like, a submarine has gone all the way down to the bottom of the ocean, the deepest point, and imaged the ground. That was a tremendous accomplishment. And in theory, of course, you could go and check out another place and another place, but to to scan the surface of the entire ocean to take photographs of every part of the ocean is very difficult. Water is hard to see through, and it has tremendous pressure. So the forces involved are mind-bending. While, to go to another planet, yeah, you need a lot of energy to get your spacecraft up into space, but then it just goes around and around and around, and it's just looking through space, and it's easy to look through space. There's nothing in it, right? Super easy. So, that's why, you send a spacecraft to Mars, you get it into the right orbit with a good camera, and it can image every single part of the Martian surface or every single part of the lunar surface. But to fully explore the Earth's oceans is a much more complicated task, and that's why you explore the stuff that's easy. To get to the oceans of Europa is going to be more complicated than, I think, exploring the oceans of Earth, because then you've got to do both, right? You've got to get to space, and then you've got to get through 10 to 100 kilometers of ice, and then you're in the environment that's like the ocean. So it is an enormous challenge, but it's like the reason you want to do it is because it is not like the Earth. It is a whole other world. So yeah, people have gone down to the bottom of the ocean and they didn't see cities. They saw rocks and dirt and interesting life forms, which we should definitely go back and study them a little better. But they didn't see something incredibly surprising that completely changed our comprehension of life in the universe. So when you think about going to a place like Europa, I mean, there could be life there. And if you find life there, does that mean that the life formed independently from Earth? And if the life is related to Earth, how did it get there? And if it's not, does that mean that there's life everywhere? And if there's life everywhere, where is it? Why don't we see it? So there are some really deep and philosophical questions that we have to ask ourselves as we think about exploring places like Europa. And that's why it's so compelling. And Dr. Elcott is saying also the ice fishing. Yeah, the ice fishing I'm sure would be incredible on Europa. So, Andrew Planet, if we use a solar sail to travel to another star, won't it be slowed down to the point of stopping by the photons of that star? Therefore, it's impossible unless we tack. No. So if you accelerate a solar sail to 10% the speed of light and you aim it at another star system, it will smash into the star. So, and if you don't quite aim at the star, it will fly past the star system and off into deep space on an interstellar trajectory. The likes of which, Oumuamua could scarcely dream of. So, in fact, one of the big problems with these ideas of these laser-powered solar sails is that they will just zip right through the star system that they're trying to study. You get a couple of pictures, you get a few weeks of being relatively close to the star system. You're taking a bunch of pictures, you're sending data home, and then your spacecraft is off into space again. Similar to what happened with New Horizons, right? Like, wouldn't it be great if the New Horizons mission could go to Pluto and orbit around the world and study it at depth? That would be incredible, but it's a lot easier to just send a flyby than it is to send a mission that's going to actually go into orbit and study it for a long period of time. Same thing with a mission to another star system. It's much more complicated to actually be able to, astronomers or scientists wish they would decelerate purely from the power of the photons alone to be able to go into orbit around the star. But it's, any shot that you shoot is going to go past the star system, and you'll get some pictures, but that's it. Let's see. Let's go back. Hopefully I've answered a bunch of questions. Matt Jono 2. Hey Fraser, if you had the technology, would it be possible to use Ceres or Vesta as a moon of Mars for its tidal forces warming up Mars's interior? So if you took all of the asteroids in the entire asteroid belt and you squished them all together, you would end up with an object that has 5% the mass of the Earth's moon. So it is not as much mass as you think, and Ceres and Vesta are small. They would cause some tidal. They would be far more significant than Phobos or Deimos, which are teeny tiny, but they wouldn't cause that much of a difference to Mars. And again, right? Think about the forces involved, the time, the energy to move a asteroid from the asteroid belt to be able to do an intercept orbit with Mars and to be able to capture it and be able to have it stay there. So I guess we'll have to find out. So Michael Gian asks, why is Hubble's constant increasing? Dark energy, I'm told, but is it a flat linear rate or changing at some variable rate? So this is the big question. So for people who don't know, of course, and I've got 5 minutes. Explain dark energy in 5 minutes. Dark energy is this mysterious force that's accelerating the expansion of the universe. It was discovered 20 years ago. Nobel Prizes for everyone. And it was discovered by analyzing the rate at which galaxies containing a certain kind of supernova were going off, and they were able to determine the distance to these galaxies. And instead of these galaxies moving at a rate that astronomers expected, they were accelerating away from us. So there is this force that is everywhere. And so the question then is this force constant? So in every time you get a new cubic meter of space, do you get the same amount of dark energy? Or is that amount of dark energy increasing over time or decreasing over time? And the jury is still out on this. Astronomers are still trying to measure dark energy with more and more precision to answer this question, because the implications are, right, if dark energy is increasing, then over time, things are going to go faster and faster. And in fact, the amount of sort of repulsive force will be stronger and stronger until you get to this point where galaxies tear themselves apart and solar systems tear themselves apart and planets tear themselves apart and your atom, you get torn apart and black holes get torn apart. And the entire universe is just this soup of particles that were torn apart. And that's the idea of the big rip. That would suck, and it would happen sooner than the heat death, which is a whole other kind of terrible outcome for the universe. So right now, this is the question. Has the expansion rate of the universe changed over the history of the billions of years? Right now, astronomers have measured the expansion rate of the universe at different times and found different numbers. So there's something weird going on, but astronomers don't know which way to go. And this is, back to the thing I talked about earlier. We're in the middle of a mystery. We don't know the answer. We are watching as the data accumulates, and we will find out over time. We'll go like, oh, we thought dark energy was constant, but it turns out it changed. And at the beginning of the universe, it was this. Later on, it was that. And in the future, it'll be this. And we can measure it very accurately. But we're not there yet. More experiments necessary. More measurements are required. I can't wait to see how it all turns out, or to watch this unfold. And I will report it to you play by play, right? Like, why do you watch a sports game, a sports ball game, right? If you want to watch and get caught up in the various plays and the players winning goals. I don't watch a lot of sports. So it's the same thing. It's conflict. There is drama. There is, and then we'll have resolution as we find out the answer. And it's something we all get to enjoy. So be patient. Let's figure it out. All right, reached the end of our hour. Thank you everyone for watching today. I'm just polishing up an episode on exploring the shadow craters on the moon to be able to search for water ice. So that should be coming out in the next couple of days. We have another weekly space hangout this week, another episode of Astronomy Cast on Friday. We're going to have another virtual star party on Sunday night. So plenty of good, fun, entertaining things coming up. Stay tuned. Thanks to all the moderators. Thanks everyone watching both on YouTube and on Twitch. We couldn't do this without you. And of course, as I mentioned earlier, if you want to be one of the people who invites guests for me to interview, go to the Weekly Space Hangout crew, wshcrew.space. They will hook you up, they'll put you to work, and you can reach out and contact the people that you want me to interview. I'm happy to do it. All right, we'll see you all next week.